Okay, we're going to practice with our geometric sequences here. So let's just go ahead and add a definition of what a geometric sequence is. You probably already watched the toolkit video, so you have a sense of what it is, but it is a sequence of numbers in which the ratio, we'll call that ratio B, remains constant. And our common ratio that we have here, we're going to call that common ratio. We're going to use the same variable. We're going to use B for that common ratio, is found by dividing each term by its previous term. Okay, so let's take a look here at our first one. So we have identifying our sequences here. First, we want to determine whether the sequence is a geometric sequence, and if it is, then we want to identify what that common ratio is. So here we're looking from 2 to 10 to 50 to 250. We can kind of see here that 2 multiplied with 5 is 10, 10 multiplied with 5 is 50, 50 multiplied with 5 is 250. But if we weren't sure what that common ratio is, we would basically take any term number. Let's take 2, we'll multiply it by B, and we'll get the next number, 10. And that's why we say it's basically found by dividing each term by its previous term. Because what we would have to do here is we would have to divide both sides by 2, and that gives me a value of 5. Okay, so yes, our common ratio is 5 for this one. And then if you want to on your calculator, you can check for all of it that it does work. So we can do 2 times 5 is 10, times 5 again is 50, times 5 again is 250. So this is yes, and our common ratio is 5 here. Okay. On our second one here, we'll skip the step of setting up the equation. So we would technically write 135b equals 45. But if we want to, we can just go ahead and take one term. Let's just take 45, and let's divide it by our previous term, 135. And we're getting 0.3, so it's basically a third. You might want to try that here. We can take 5, we can divide it by its previous term, 15. Oh, good, we're getting the same ratio, 15 divided by its previous term, 45. So yes, this is a geometric sequence, and it looks like we're continuously multiplying by a third, or 0.3 repeating. So if you wanted to, you could just do this, and then let's multiply it by 1/3. Great, we're getting 45. Let's multiply by 1/3 again. 15. Let's multiply by 1/3 again. And we're getting 5. So yes, we'll say that our common ratio is a third. I'm okay with you also, expressing it as 0.3 repeating. That's fine as well. Let's do one more sequence together. So we have 6 multiplied with some number is giving us 18. The way we would then solve for that is we would have to divide by 6 on both sides. So let's take 18, let's divide it by the number that comes before it, and that would be 3. So now we can say, okay, well, let's see if that common ratio is consistent. So 6, let's multiply it with 3. Okay, that gives us 18. Let's multiply that with 3 again. Ooh, and that does not give us the number 24. So this is not a consistent sequence, not a geometric sequence at least. So we would just say no for this one. And if you wanted to, you could say here, your work would be multiplying by 3. And then this here is not the same pattern. And you may be able to figure out some type of pattern that exists within the same within the sequence of numbers, but it might not be just a consistent value that you're multiplying by. Okay, so you're going to continue with that with question 4, 5, and 6. So try to determine, is there a number that you're taking 7, multiplying it by to get the next term, and then can you repeat that for the rest of the numbers in the sequence? And same with question 5 and 6. And in questions 7 through 10, given the sequence, find the next three terms. So you're not having to decide, is it a common ratio or not, or is it a geometric sequence or not? So it is telling you that it is. So let's just do one example together. So our first number is 7. What would we multiply 7 with to make negative 21? So if we wrote out the equation 7b equals negative 21, we'd have to divide by 7 on both sides. So that would be negative 3, right? So we're taking any number that's in our sequence, we're multiplying or dividing it by the number that came before it, and that would be our common ratio. So our common ratio is negative 3, so 7 times negative 3. Okay, that's negative 21. Let's times negative 3 again. 63 times negative 3. That would be negative 189. Let's multiply with negative 3 again. And let's multiply with negative 3 again. Okay, so you'll try questions 8, 9, and 10 on your own. And then this should look familiar from our toolkit. So let's just write out our formula again. So it's a sub n equals our 0th term multiplied with our common ratio to the nth term. So remember, n is our term number. And when we're writing out our rule, we have a sub 0, that's our 0th term. And we're always starting with our first term, so we have to kind of backtrack to get our 0th term. And then b, that's still our common ratio. Okay, so let's try the first question together. 3 is our first term, 9 is our second term, 27 is our third term. So we're looking for a common ratio. So we can take any number there. Take, for example, 9. If I divide it by 3, that will give me a value of 3. So that means our common ratio is 3. 3 times 3 is 9. 9 times 3 is 27, and so forth. And that will continue on that list. So if I want to figure out the 0th term, the number that comes before that, instead of multiplying by 3, I'm actually going to have to do the opposite, and I'm going to have to divide by 3. So 3, if I were to divide that by 3, would be 1. So my 0th term, if I were to redo this list and put another term in front of it, would be 1. So we would write out our rule as a sub n equals 1, that's our 0th term, multiplied with 3 to the nth power. So this would be our formula. And then if we're trying to figure out our 7th term, we could write out a sub 7 equals 1 times 3 to the power of 7. So a sub 7 is, and we can go ahead and put this into our calculator, 1 times 3 to the power of 7. And that would be 2,187. And you should be able to get this number as well if you were to just continue the list of terms here. So 3, we're starting at 27, multiply by 3, we get 81. That's our 4th term, times 3, that's our 5th term, 6th term, and 7th term. So if we just continue that list, we should be able to get the 7th term as well. And that could just be a way that we're checking our work. Okay, so you're going to do that for question 12. You might see a few familiar problems on this page as well. And then in the last question, the only difference here is that you are seeing your list of numbers in a table instead of written out as a list. So you still are going to want to get your 0th term. So imagine, let's pretend there's a year 0. So what would you have here for the initial value? We could call that, or the 0th term. Okay. And then we're looking for after 3 years. So the table to the left shows a car's value for 3 years after it's purchased. Okay, so here we have year 3. And then what we're looking for is if we had the 10th term. So then you would just be saying, okay, well, what is a sub 10 in this case? So you can technically continue this list, right? And we can multiply and figure out, well, what's our common ratio? What's depreciating in value? So that means the car is, worth less every single year. So we just need to figure out, well, what does 10,000 mean multiplied by to get 8,000? Which is then multiplied by that same number again to get 6,400, okay? So then you're figuring out the price of the car after 10 years.